Hi guys, and welcome to this next video. Now first of all, now that we are done with the information gathering, it is really important that you actually go one more time through all of those tools that we covered, as well as find out more tools that we didn't really cover and check them out as well. Okay, so right now we're going to get into the scanning part of a penetration test, which is as important as footprinting because we are still gathering enough information for our target to execute the attack. Now, before we actually begin with the practical lessons, I will open up my LeapPad right here and we're going to define a few stuff or terminology that you might need to know in order to understand scanning on a whole nother level. So first of all, we need to define what a network is. So a network, let us just type it right here. A network is simply a connection between different hosts. So is a connection between different hosts. It is also how hosts communicate, so we'll just type that as well. It is also how hosts communicate. Now, for example, all devices in your house connected to the same router belong to the same local network and they can communicate between each other. So network is, as we said, a connection between different hosts. But right now we also need to define what is a host. So a host is a device that has a unique IP address and MAC address to define it. So host is a device. It can either be, for example, your PC, your laptop, MacBook, iPhone, Android device, or basically any of that, anything that is connected to the actual internet. It can also be your fridge if it is connected to the internet. It is a host that has unique IP address and MAC address to define it. Okay, so now for all of you beginners out there, let's also explain what IP address is and MAC address is. Basically, the IP address is a unique set of numbers, so we'll just type here IP address, unique set of numbers, and it can either be local or, if you want to call it, private, which is basically the IP address that your router or DHCP assigns to you in your local network, or it can be public, be local or public, or if you want to call it external, doesn't really matter. You can use both names if you want to. The local IP address is, as I said, assigned to you in your local network, and it will be mostly something like, let's type it right here. So local IP address will look something like this, 192.168.1.5, for example. Now it all depends about your actual local subnet, because if, for example, your router is, let's say, 192.168.0.1, probably your devices will all be 192.168.0.5 or something like that. Basically, it can be from 1 to 255, but it will mostly be something like 2 or 3 or 4. Now, let's just check real quick the actual IP address on my Windows 10 machine. So I know it will start with the 192.168.1. something. So let us see right here, ipconfig. If you simply just type ipconfig on Windows and go down here to the Ethernet, or if you're connected over wireless, you can simply just check the IP address under the wireless adapter. But since I'm over cable, I have it under Ethernet, and it is 192.168.1.6. So my IP address is this one, and it is considered to be a local IP address because it can only be used inside the actual network, inside the local network, and I cannot really communicate with it outside to the internet. While as the actual public IP address is a unique IP address on the internet, and it defines your router to the world in order to be able to communicate over internet. So the public IP address can be something like 171.89.22.32, for example. This is the public IP address can be actually set of random numbers separated by 3 dots right here, and it will look something like this. So if you see an IP address like this, it will mostly always be a local IP address. And if you see something like this, it will never be a local IP address. This is the external or public IP address. Okay, so let's explain this a little bit more further. Your router actually has both public and private IP. Now the reason for that is because the public or external IP address, besides being unique, shows you where you are, and you can find out the location of a specific network just by searching the public IP in an IP geolocator, for example. So the local IP of the router is used to actually communicate with the devices inside the local network, while as the public IP or the external IP of a router is used to communicate and send data to the internet. So for example, you as a PC inside your local network want to communicate with Facebook, it will go to the local IP address, your packets will go to the local IP address of your router, but as soon as router gets them, it will send them to Facebook, and Facebook will see it from the external IP address of your router, if you understood what I mean. So simply in order to paint that a little bit better, we can simply just open Paint right here, and we can simply just draw a PC. So this is your PC. Let us draw it right here. It has the IP address of 192.168.1.6. And let me just enlarge this dot right here. Okay, and it sends packets to your router. And this is your router, let's say. It has the IP address of 192.168.1.1, but it also has the public IP address or the global IP address, which can be, for example, 171.22.89.32. And this IP address right here is used to communicate with the local hosts in the actual local network, while as this IP address can be used to communicate with the actual outside network or outside internet, for example, facebook.com. So let's just type right here, Facebook. Now pardon me for my actual writing, Facebook. And therefore, the outgoing connection from the router to the internet is going over this IP address right here. Let's also mention, now that we explained what IP address is, what kind of IP addresses are there, let's also explain what your router or your gateway is. So the gateway, or simply your router, is a network device that all the traffic from local network to the internet passes through. It also runs a bunch of services on different ports and has a firewall inside that can filter out the traffic. Now, the firewall inside is just a piece of software that basically filtrates the traffic. It works with different rules that can block or allow communication using those rules. So before we actually continue, let us write all of that. This is public IP. Now let's define what a router or gateway are. Network device that all the traffic from local network to the internet passes through. It also runs a bunch of services on different ports and has a firewall inside. Oops. That can filter out the traffic. Okay, so this is our router, and a firewall we can simply define to be a piece of software, and it can also be a hardware, so a piece of software or hardware that filtrates the traffic. Okay, it basically works, as we said, with different rules that can block or allow connections using these rules. So let us just type right here, it works with different rules. Okay, now its main purpose is basically to secure the network. It is logical, so our firewall basically secures the network as it filtrates different types of packets that come and go through our router. Now, machines and routers both have services running on them, so those services use specific ports for outgoing and incoming, and incoming traffic. Okay, so to define a port, we could say a port is a number representing the endpoint communication. Now, every service has its own port, and with ports, machines basically know how to communicate with each other. Every port is also unique for a specific host, and ports can be either open, closed, or filtered. Okay, so let's define a port right here. Is a number representing the endpoint communication. This is how machines communicate, and every port is unique for the host. Okay, so different types: open, closed, and filter. Now the open port is simply a port that is open, as it says right here. The closed port is a port that doesn't have any service running on it, therefore it is closed, or it is not open to the public. It can be open to, for example, a local network, and closed to the outside internet, so it can be also something like that. And the filtered port is a port that actually has some firewall rules over it, therefore it filters the traffic. Okay. For example, once you, let's say, visit a website, you're simply searching for the service that is running on port 80, because all of the websites by default are running over port 80. So we can simply just take a look at that. If we open up our Firefox right here, and simply let's search facebook.com. In order to specify a port that you want to visit, you simply just type 2 dots after the domain and type port 80. Okay, and what this will do is it will lead you to the Facebook page, the regular Facebook page that we see all the time. But if you, for example, type, let's say, facebook.com, and you simply just type port 93, now by default, if you don't really specify a port and you simply just type Facebook, it will by default go to the port 80, which is, as we said, the port for HTTP. Now the port for HTTPS is 443. So we can see once we actually type facebook.com, it redirects us to the HTTPS, which is a secured version of HTTP, and therefore this is running over port 443. If you visit a website that doesn't have HTTPS and it is only running over HTTP, it will by default go over port 80. Okay, so we can see it is still loading our facebook.com over port 93, and it will most likely not find anything on that port. So if you simply just specify a port that isn't being used, it will not load a page. So that is also something you should know. Now let us close this since we don't need it. Let us also close this. This is just some scripts to remember. We need to define all of this, and we did define all of this, so you should simply just learn it and don't forget it, because it will be useful for us once we start scanning in the next video. So let me just close this right here. We don't want to save it. And now that we know the network terminology, let's see why network scanning is basically useful to us. First of all, we can discover all hosts available on the network. We can map the network and understand how it works in a more detailed level. Once we actually scan the entire network, we will have a clear look at different hosts that are up and running on the network, and then we can target one of them in order to discover what services it runs on open ports and whether those versions of services are vulnerable to a certain attack. Now don't worry, we will cover all of this in practical for now. I am just explaining in theory just what scanning is. Basically, the purpose of scanning is simply just to seek for vulnerabilities. And once we find a vulnerability, we can start planning the attack. Now, at the end, let's mention a few tools that are used for network scanning. So we have Nmap as most used tool and most advanced tool for network scanning. And we also have its graphical interface version, which is ZenMap. Now, there are also different tools that we can use, such as AMAP, which is something similar to the Nmap. We can use some tools that basically come in Kali Linux, for example, Ping tool, Traceroute tool, and there are a bunch of other scanning tools, such as, for example, NetDiscover, BetterCap, Wireshark, TCPDump, Armitage, and so on and so on. Of course, there are others, but these are just some of the most famous ones. Okay, so now that we are done with the actual theory part, we can continue in the next tutorial and actually perform some of the practical lessons of scanning networks. Hope I see you there, and take care. Bye.